Hey everybody, my name's Cameron, and by way of introduction, I have a couple of jobs right now. I've been a software developer for a long time, but right now I do a bunch of things. And one of them, my main job, is I'm a CTO at a company called TRX that does online trading of television content rights, the big application written in Rails. And I used to run a company called Mint, which is a product agency based in London and New York. And I sit on the board of Boomph, which is the marshmallows that Desmond was alluding to. They are indeed edible. They're not vegetarian, just in case anybody wondered about that. And the ink is not poisonous in any way, as far as I know. So Rails was the common thread around all of these things. And it's important for me to tell you that just because this talk is about my journey coming to Elixir and some of the difficulties that I ran into, and maybe some insights I had that I wished I kind of would have known then. So the year was 2014, and in October, and like I said, I'd been building Ruby apps and Rails apps for 10 years, and then this book comes out, and I said, oh my God, Dave Thomas, I'll just read anything he writes at this point. And so I read the book, and I got really fired up about Elixir and OTP, and I'd looked at Erlang in like 07 or something like that, and just I was excited about OTP then, but I just really I couldn't really get my head around it. I never really built anything serious with it, and never went anywhere. And so I was like, okay, this is cool. I'll learn this language, and this looks really great. And it just historically, these are languages that I've learned pretty seriously over the years. I've done all of these professionally in one way or another. And my approach to learning a language was that you read the book, and you more or less get your head around it, and then you build a big project in it. You do something enormous. Maybe not enormous, but sufficiently ambitious that you're going to explore all the nooks and crannies. And by the time you've gotten to the end of it, and you've solved all the problems that you inevitably run into with these languages, you'll have learned the language pretty deeply. And so that's what I tried to do. And it did not work at all. And I found myself in a place where I knew I was running into the usual kinds of problems that you run into with these big projects, but I didn't feel like I was getting particularly close to the solution. I felt like I was running down a lot of blind alleys. And probably spent about 6 weeks doing this, and I was like, man, I'm making progress here, but I'm pretty certain this is a pile of crap. So, not Elixir, my shit, right? And so then, work, I have a lot of jobs, and stuff started going crazy, and I had to put it down. And I didn't really pick it up again for probably 6 months or so. And then had a little bit of free time, and I can't remember why, but I was like, I got to take a look at Elixir again. And so I went back, and I read the book again. I read the book right the way through, only this time I did all the exercises, 100% of the exercises. And that was pretty useful. And then I didn't do a big project. And this was the key, right? I didn't do a big project. I didn't have that much time, and maybe I was a little gun shy from the last time around. I just kind of all the time, like any free moment, I was just doing little exercises. I was going to different places. Like I was going to Project Euler, and I was doing all the beginning exercises on Project Euler. And Advent of Code came along, and I did like almost all of the puzzles on Advent of Code. If you guys haven't seen that, it's brilliant fun. And I did all the exorcism.io problems for Elixir. And it's just really weird. What I discovered was that many small projects was much, much more effective for me than that one big project. I mean, this time, it really stuck for me. I really understood the language, and I really had a good handle on it. And the thing was, I wanted to understand this so that I could drive OTP. I wanted to get all these benefits of fault tolerance and concurrency, and I was willing to put up with the pain of this new paradigm as like the price of entry, as like the ticket price, in order to get all of that benefit. But what I discovered was that within about 2 months, maybe less, I'm faster in Elixir now than any programming language I've ever worked with. For doing simple things, for doing complicated things, I'm quicker. and I'm writing code much more correctly. And I thought, this is just weird, right? Because the language isn't magic. It's not like, it's no more magical than Ruby. It's much less magical, in fact. So what was it? Well, what happened here? Well, did I finally grasp OTP? That a lot of people will tell you that that the hard part of learning Erlang or learning Elixir is understanding the concurrency model, and that may be true. For some folks, it wasn't. I don't think it was true for me. I grasped the concurrency model quickly. It was other aspects of it. It was, for me, something that I'm calling micropatterns, and I invented this word, I think, which means it's probably not that meaningful. But I just wanted to. I was thinking about just the little patterns that you use, not idioms, not things that vary very specifically from programming language to programming language, but just the little patterns that you use to achieve small results when you're writing code, when you're writing simple code. And I called it micropatterns because I didn't want it to be related to this thing, right? I'm not talking about facades, and I'm not talking about singletons, and I'm not talking about any of the crazy crap that's in that book, right? Those are big architectural patterns, very important if you're doing object-oriented programming, not so important in Elixir. And to illustrate, I have a simple example. This is in Ruby. And so this example is basically a simple function, and all it's trying to do, it's trying to turn it. I actually lifted this out of the Faker gem, if you're interested. It's taking a num, and it's trying to return some list of categories, some array of categories, and it wants to return. But why wouldn't it just do it, n times? Well, because it's generating the categories randomly, and it wants them to all be unique, but it also wants to return the exact number that you sent. So in Ruby, they're creating an array, and then they're adding crap to the array as they get a new one that's not included already. And there's nothing wrong with this. I'm not beating up this code or anything. This is fine. But if you try to do this in Elixir, you're going to have a problem, because this pattern it requires mutability, and this was the big issue. I knew, of course, I know it's immutable, but people know it's immutable. There's knowing it's immutable, and then there's knowing what to do about it. And they're two different things. And so, if you think about mutation versus transformation in Elixir and in other functional languages, you just have to stop thinking about mutation and focus only on transformation. So that brings me to the first micropattern, which you all know and which everybody talks about all the time, and that's pipelines, right? And the nice thing about pipelines is, first of all, they're intuitive and we understand them straight away. But I think, second of all, they enforce the fact that we're doing transformations. If you've got a function and it's nothing but a pipeline, you know for sure that that's a transformation, and there's no mutability or no mutations happening there. So here's a real-world example, and by real-world I mean a completely contrived example that I have concocted for the sole purpose of demonstrating micropatterns. So the idea is, your boss comes to you and he says to you, hey, you know what? I've been keeping track of the employees in the company, the org chart in the company, using Excel for many years, and I've got this Excel spreadsheet, and I want you to import it into some programming language, and I want you to use it to tell me a bunch of stuff. And so you've got this CSV, basically, right? And it's got the ID, the first name, last name, and then the ID of the manager, and then the salary of the employee or something. And so you say, okay, well, I want that to be a list of employee structs. Nothing crazy there. So what I do, and maybe many of you do, is I have like a workflow where I basically say, okay, here's what I'm going to want to do. I want to transform. And I'm using a pipeline to do it. So I'm going to transform the file name into the file contents, into some sort of parsed data, and then through some validation step because he's been just managing this by hand in Excel. So obviously there's going to be mistakes, and I want to be able to catch those mistakes. And so, and then these are sort of, each of these themselves could be, they're all transformations as well, and they could all potentially use the pipeline. And so if we have the read, well, that's just a pipeline too. So read is just take the file name, turn it into the file contents, split it on the new line, and then do something, right? And that something is another pattern. Now, many of you have done this, if not all of you. But when I first started looking at Elixir, I only half understood what was going on here, right? I knew intuitively, because this exists in Ruby, right? That you can do precisely this in Ruby, except you're passing it a block and then there's a yield or something like that. But it's a little bit different in Elixir, because what we're actually doing here is we're passing split, string.split to map. Now, map, we're handing a strategy to map and telling map, hey, here's the strategy that you're going to use, and it's a function. But map takes a one-arity function, right? That always, it just passes each element to the function. But string.split too is a two-arity function. So what do we do about that? And this is what we're actually doing. Now, when you say ampersand string.split, ampersand 1, comma, that actually returns a function, right? I mean, it sounds stupid. It took me a long time to figure this out. So that returns a one-arity function, and you can see that. So string.split now, that expression returns a one-arity function, and that one-arity function can then be passed to things or put into variables. And so you could even say, hey, I've got a variable called split by comma, and it equals that expression, and now I've got a function, and then I can call that with split by comma. And so that's what we're doing there, and that's another micropattern. It's just functions as strategy, functions as visitors, functions as all the things that you might build larger patterns in other languages out of, right? And so then, yeah, we can do this, and now we get something or other. And now we go back to our original pattern, our original pipeline, and we want to look at how we're going to parse this thing. And this is the third, what I would consider a micropattern. And that is handling the happy case using pattern matching. And in many cases, the problem is broken down, the problem is bigger than you can hold in your head. In this case, the problem is not that big, so you can quite easily hold it in your head. But in some cases, the problem's just too big to hold in your head. And in Elixir, a fantastic thing to do is to say, well, okay, there's just this one little piece of the problem that I thoroughly understand. It's one case, and I'm just going to handle that case with a pattern match. And what I'm going to do in this case is I'm going to say, okay, I'm expecting a list of strings, and they're each, and there's 5 of them, always. Right, that's what I'm expecting, and that's what that's what I intend to get. So I'm just creating my parse record function. It literally just takes a list of 5 always, right? And then what it returns is just the struct with the integers properly turned into integers, etc. It begs the question, well, what if there's not 5 things in the list, right? Well, if there's not 5 things in the list, you presumably need to handle another case. I mean, it'll crash otherwise. Now, in this case, for this particular problem, that's actually exactly the behavior I want. I want it to crash because I want to know if this crappy spreadsheet he's given me has got really problematic data in it. Okay, so that's the second pattern or third pattern. And I'm going to tie all these together sort of toward the end. But then the last thing we want to do is validate. And so this brings me to a sort of another pattern, which is how, in an object-oriented world, I would just have, the object would just know whether or not it's valid or not. It would apply its business rules, maybe just in time. Maybe you'd ask the object, are you valid? And it would look right at this moment, I am valid or I'm not valid. But we're not dealing with objects. We're dealing with just data, just structured data. So what are we going to do? How are we going to handle transformation? So in this case, here's our employee object. And if you look, we can just add additional metadata to that. And this is a very common thing to do. This is not so common in object-oriented languages. You might split off other objects, or you might not even have objects for this. But I've noticed in Elixir, in things like Phoenix, there's a tendency to aggregate data as necessary in order to implement the functions that you have in mind. And so in this case, we're just going to add an errors list to to our employee. And this is going to allow us to do things like this. We're going to be able to say, okay, well, how do I implement valid? Well, I handle the happy case. I say, okay, well, I pattern match employee and it's got an empty list of errors. Well, then that's true. Otherwise, it's false, right? This is not news to anyone, right? And then if I can implement add error, add error just basically takes an employee and it takes an error, and it adds that error to the list of errors. That's all it does. And so now we could perform validations with that. We have kind of what we need. But I'm not going to perform validations because there are too many micropatterns, and I had a whole bunch more I could talk about there, but there's not enough time. So I'm going to skip that because I don't want to shortchange you on the final thing that I want to talk about, which is the number one thing that people seem to struggle with, seem to find difficult when they move to this world, and that is recursion. Recursion. So now, the reason recursion, I think, is a little bit scary is because, especially if you're coming from an imperative language, this really is the bastard. And it's because, I mean, like I said, I've been doing this a long time. And back in the 90s, we did recursion in job interviews. You'd have to write recursive things, and you learned it in college as like a theoretical thing that you're supposed to know. But I was really trying to think about it. I definitely, prior to Elixir, never wrote a piece of recursive code to solve an actual problem. Right? It was only ever to prove what an awesome dev I was. But in functional languages, this is how you mutate state. You must recurse, or you don't have any other way to do it. You must use recursion. And so I'm going to hopefully show a couple of things, because in the beginning, when I was working with Elixir, I was trying to think about how to solve these problems recursively, and it was all a big puzzle, and I'd really ruminate about it, and then I'd figure it out, and I'd come back and I'd solve it. But it's like, I'm a professional software developer. I don't want to be having like great moments of insight when solving these kinds of problems. I want to be able to methodically and predictably implement solutions to things. And so, no? So there's a couple of tricks with recursion that might make that more possible. Nothing's going to help besides practice, but there's a couple things. So let's go back to our original Ruby example, right? You can't solve this with mutation. You must solve this with recursion. So for the sake of argument, this example requires a function called fetch, which returns a random something or other. I'm just going to implement an example fetch, which just returns a random number from 1 to 100. Fine. So first of all, I know I'm going to have to be maintaining some kind of state because I'm going to need to be checking if things are in the list. So I know right away that there's this pattern where I'm taking categories n and I'm turning it into categories n and an empty list, because that's going to be, I haven't created anything yet, so that's the empty list. So the notion of taking a one-arity function and immediately calling a helper two-arity function is a common pattern. But the first rule of recursion is to first consider the termination clause. What's the termination condition here? When am I actually going to be done with this thing? Under what circumstances? And so, well, there may be more than one. In this case, the obvious termination clause is 0. If I'm not asking for any elements, then I can just return what I've got. And that's it. I can't really think of another termination clause. And then you think about the recursive step. And when you think about the recursive step, you just have to ensure that every aspect of the recursion gets you closer to the termination clause, if that makes sense. And so in this case, all I'm doing is I say, okay, fetch category, and if it's already in the result, I just recurse without doing anything. And if it is in the result, I subtract 1 from n, bringing us closer to the termination clause. And any time that you're sure that you're coming closer to the termination clause, your recursion will terminate. Now this code, if you're eagle-eyed, you'll observe that this code will not always terminate because because we're generating a random number. And if we ask for something, if we ask for more elements than fetch category will actually return, like 150 or something, this will never terminate. And the same bug actually exists in the Ruby code. But it's a little more obvious here because you can see right away that my recursion clause quite obviously will not always get us closer to the termination condition. So, all right, I want to step back for a minute. Why are we learning all of these micropatterns? Like, why aren't we just letting this knowledge kind of evolve as we use Phoenix to build bigger sort of general projects and stuff like that. There's two reasons. One is that, yes, if you learn all of these micropatterns, I promise, and if you practice them and do lots and lots and lots of little problems, I promise you will become, if you're struggling at all, you will become a hell of a lot faster writing Elixir, probably faster than any language you've used, in my opinion. The other reason is that in Elixir, micropatterns and big patterns are the same for the most part. As I was researching this talk, I came across this other talk by a guy called Scott Vlashin, and this is on YouTube, and it's in F#, but everybody should see this. It's really good. It's called Functional Design Patterns, and he had an insight that he mentioned in there where he talked about. He said, in object-oriented programming, you have objects in the small. We talk about objects in the small, or objects in the large, sorry, and methods in the small. And in functional programming, we have functions in the large and functions in the small. It's all just functions. And that makes a lot of sense, right? When you're doing object-oriented programming, it's like figuring out the object hierarchies and all of the architectures around that is almost a different discipline to what you're doing when you're writing the methods to drive those objects. But in Elixir, it's the same. It's like so for example, when we added the error to the struct, it didn't really seem like anything, that's no great noise, right? We added an error to a struct, takes an employee, takes an error, sticks the error onto the list of errors in the employee, like not rocket science, right? But that's how plugs work in Phoenix. And so if you understand that little tiny thing, and if you use that regularly in your code, then you will understand how plugs work. And so and plugs is pretty much the entire architecture of Phoenix from one end to the other. So it's a fractal. It's a self-similar kind of thing. Okay, now this is where this might or might not work. Let's say we don't just want to read in all of the employees and do some validations on them. Let's say we want to take that list of employees that we had, and we want to turn it into a tree, the proper org chart with the big boss on the top, and each employee structure carries a list of all the other employee structures, inside of which are lists of the other employee structures. So we have a nice, end tree that we can then maybe manipulate and figure out different characteristics of the organization. This is a big problem. This is the kind of thing that you might have to ruminate over for quite a bit. So where to start with something like this, right? Like this is the kind of problem where you'd like to just solve it and not have to understand it all in its total complexity. So where to start? Well, the top of the tree, I need to find the big boss, right? I need to find whoever's on the top of this organization, and then they're the org. So let's suppose it would be really handy if I had a function that would take an org with the top of an org and an employee, and it would return a new org with that employee added if possible. Like this. So I'd say, okay, add a report, and the report would take the org and the new employee, and it would return the new thing, right? So now, to catch the big boss is easy. All we're going to do is match on anybody with a nil manager is clearly the CEO or whatever, and we can just add them, and if we're adding them to the nil organization, we know that they themselves are the organization so far. That's great. Well, if we're adding somebody who is not a boss, i.e. the manager wasn't nil, and we're trying to add them to a nil organization, we know we can't do that because they're not the boss. So we now have two of the edge cases handled. And then we have a third one, which is, okay, this is the really happy case, right? This is, I'm being handed an employee as the potential manager, and I'm being handed an employee as a report, and they correctly match up. So the ID of the manager matches the manager ID of the employee. Boom. I can add this employee to the list of the manager's reports. Sweet. And then the other possibility is that the new report, he doesn't work for the manager that is being handled, but maybe reports to one of that manager's reports further down the chain. And so in this case, all I'm going to do is I'm going to map over the reports, and I'm going to try calling it on each one. And I know that I'm always getting closer to I'm recursing, but I know I'm getting closer to the termination condition, because if that reports array is ever, or that reports list is ever empty, that Enum.map is just going to fall through. So I know that I'm always getting closer. Right? But that's not good enough, because I don't know that I'm getting these employees in order. I don't know that I'm going to have the manager before I have the reports for that manager. So I have to deal with that somehow. And I'm going to deal with that in an arguably non-optimal way. So before you Elixir geniuses start calling me out on it, I know it's non-optimal. I tried to make it easy to understand. So we're going to write add all reports. And this is going to take a list of reports and an organization. And it's going to try to add all of the reports in the list to the organization. Okay, so what's the termination case? Well, one termination case is there's no reports to add, in which case, fine, so that's the org, done. In fact, that's the only termination case in this case, so that'll do. And then we have to think about what do we do the rest of the time. So in the rest of the time, we're adding all reports. What do? Well, we take a report off the list, and we're adding that report, hopefully, to the organization. And so let's see what happens. So we can say, try to add report. And one of two things is going to happen. Either that organization is going to be unchanged because the report couldn't be added, or the organization is going to be different because we did actually successfully add that report. Well, why would it be unchanged? It'd be unchanged if the manager, the correct manager, just wasn't there, probably because we haven't read them yet. We haven't processed them yet. So the way we can do that is by pinning the org in the case, so that forces the org to bind to it doesn't allow it to rebind, basically. And so this is the case where the org hasn't changed, and we know we failed to add it. So what are we going to do? Well, what I'm going to do is I'm going to just move them to the end of the list. And hopefully by the time we get to him again, we'll have found his manager, right? And so I'm just going to call it recurse on add all reports, head him to the end of the list, and call org. Now this is arguably not getting us closer to the termination condition if the data is flawed. If there's an issue where I'm never going to get this guy's manager, then this won't work. But if the data is correct, this is guaranteed to get us closer to termination. And this is, well, there's a different org, and in this case, I can pull that report off the list, and I can call add all reports on the rest, and hand it the new org. And this is definitely getting me closer, because the list is smaller than it was before. Simple, right? Everybody found that straightforward? Well, if not, it's okay. I think, for those of you who found that obvious, congratulations. If any of you found that maybe not so obvious, I suggest just doing that again and again and again, because it really does become pretty straightforward pretty quickly, and well, just quicker than you think. And I think that I'm not saying don't do a big ambitious project necessarily. I'm saying do a big ambitious project, and also spend some time doing small problems. And if you did find that obvious, it's possible that you have colleagues or friends who are trying to learn this. And I myself have been teaching, helping like 2 or 3 people to learn this language. And I found that this kind of thing really helped them. So what do I suggest for next steps? Do small problems, use new patterns. The small problems are better than the larger ones because you can use more of the patterns. You don't spend as much time digging up stuff around the API or things like that. Where to find the small problems? As I mentioned, advent of code, exercism. There's a book called Exercises for Programmers that has quite a lot of acceptable, appropriate ones. And there's a few guys that work with me had great success with the little schemer. There's a blog post on Lucid Simple about using the little schemer to learn Elixir, which seems like crazy talk. But but actually it's a really effective way. If you struggle at all with like recursion or dealing with higher order functions, that book is tremendous. And you can just do all of the exercises in there in Elixir. And it basically, it is essentially an entire book of little problems that you do over and over and over again until it becomes obvious. The other thing is read the Elixir source. It is, as Brian mentioned, the Elixir source is actually really accessible. And as you look through there, if you try to understand these things, you're going to see some of these kinds of patterns, and you're going to find new patterns that you can then apply. And then just, do it again and again and again, and mix things in with your big small projects and with your big projects. And then finally, stay in touch. I'm Cameron P. on all of these social networks: Twitter, Medium, GitHub, Gmail, and the Elixir Slack. And I'm quite happy to talk to anybody about this stuff. I'd quite like to put together a GitHub repo with a lot of the little patterns, and I'll be probably tweeting about that and talking about that soon. And I'll be absolutely seeking pull requests or help with those kinds of things, especially if you feel like I'm full of shit about some of these patterns. I would appreciate that feedback very much. Thanks. Questions? Sorry, it's very hard to see you. Yes.
Hi. So when teaching other developers these things, the idea of using recursion to fix a problem, that might make sense. The things I did in Ruby, when I'm teaching a junior developer, Elixir out of the box, like when I point them at some of these things, like is there any place where some of these micropatterns get surfaced, but wouldn't necessarily be? I mean, like recursion isn't necessarily obvious to somebody who's looking at Project 2 or.
It will be if they try to solve some of the problems. That's the thing. The problem is that if you write a Phoenix application, there's a good chance you will not encounter recursion, because what you're really doing in Phoenix is working with a DSL that happens to be written in Elixir, and you're using that DSL. But if you try to solve some of the problems on Project Euler, you won't be able to solve them without recursion. Or you'll be able to solve them, but you'll do what I did at the beginning. You'll create agents, and you'll use those agents as like little puddles of mutable state. And then you'll be able to apply all the old patterns because you've got an agent. Don't do that. Agents are probably a code smell until you're a little more advanced, I think. But the little schemer is fantastic for problems that require recursion. But frankly, most problems that would have required mutation in imperative languages do require recursion, and should probably be done with recursion. And even if you use something like enum-reduce or Enum.map or something like that, they're recursive under the covers, right? Like you're just hiding the recursion from yourself. And so in many cases, like if you want to understand enum-reduce, it's easier to write the recursive version and then turn it into a reducer. Yes. Not in this talk, because it complicates things a little. But yes, you should aim to do tail call optimization if at all possible. Everybody's in the back.
Do you feel that one of the reasons you found it easy to take on a large project with your other language transition was, I think everything else on the slide was procedural/object-oriented, and thus it was really just libraries you were learning rather than new semantics?
No, actually, I learned C and C++ by doing precisely that, and I was at the time I was learning C. I had hardly any libraries. It was like 1989. I really genuinely think it's more the imperative nature, the patterns that emerge from imperative programming as opposed to the patterns that exist. If you wanted to write that little example Ruby function that I showed, if you wanted to write that in C, it would look much the same. Even though Ruby and C really are quite different, those two would look kind of identical. So I think learning all the libraries wasn't, I don't know, I don't think it's like the richness of the libraries. Elixir provides really rich libraries that do lots of things, and I found them very easy to understand.
One of the things I struggle with as an object-oriented programmer struggling to learn Elixir is you get experience with thinking in objects, but it's very easy to think of where the seeds are and how things break apart. And I don't, like you mentioned the fractal thing, which makes sense to me, but how do you know where to draw boundaries and like draw abstractions?
So well, setting aside concurrency, where the answer to that is longer and far beyond the scope of what I'm qualified to tell you, I think that in general, you maybe shouldn't be drawing those boundaries in a lot of cases. Those boundaries tend to exist in object-oriented programming languages because the point of objects is to encapsulate data and control data in particular ways, whereas we actually just leave the data open to the world. And so you shouldn't really be thinking about necessarily ring fencing your data. You should be thinking about just transforming your data from one thing to the other, and by any means necessary. Straight back. So the question is, I said I find myself faster in Elixir than in other languages, and does that translate into production code as well as the little problems that I'm doing? The short answer is, unfortunately, I'm not doing a lot of Elixir in production, but I am using Elixir for real problems. I am using Elixir. This problem of the boss and his list is analogous to a problem that we have in TRX, where we're getting data related to television programming from a million different sources, and we're trying to normalize it into a particular way, and we're absolutely doing that in Elixir. And we would not be as fast at it, we would not be as effective at it if we were doing it in Ruby. I'm absolutely certain of that. Okay. Thank you.